Okay guys, so welcome to the application section. We're going to do a bunch of word problems and number problems that are a little bit more, you need to do some applying of your previous knowledge to it. So the first question I have is, a theater has 20 seats in the first row, 23 seats in the second row, and 26 seats in the third row. And I want to know how to write the pattern rule for this scenario. So just like we talked about earlier, and you're going to hear me repeat it over and over and over and over again, first thing we need to do is create a term, a table. I'm getting rid of this pencil, this pen. Does this one work? Yes, okay, perfect. So I'm going to create a term number and a term value chart, okay? My first term, I've got three terms here, right? So I'm going to write 1, 2, and 3. My first term is the first number listed, it's 20. My second term is 23, and my third term is 26. Step 2, let's identify the growing or shrinking pattern. How do I get from 20 to 23? I'm going to increase by 3. And the same thing from 23 to 26, I'm going to increase by 3. At this point, you guys know by now that this 3 will be the sidekick to my variable. So 3n, again, I'm just choosing n, you can choose whatever you want. We have to test this pattern rule because it may not be correct. So let's test it. So let's do it with the first one. I can already see that 3 times 1 is definitely not going to equal 20, right? So I'm missing a huge constant here. What am I missing? How am I getting from 3 to 20? Well, I'm adding 17, right? So if I add 17 here, that becomes the constant in my pattern rule. So I'm going to add that here. Remember we talked in the last part of the knowledge section about term 0? So if I said term 0, and if we're adding 3 to get the pattern growing, to find term 0, I would do the opposite. So I would subtract 3. And if I subtracted 3 from 20, or 20 minus 3, I would get 17, which is the same number I get here. So again, you can use this strategy if this strategy is easier, or if you can understand it and you want to try it, term 0 can help you out. Here's the thing, guys. Term 0 doesn't always work, okay? So in nonlinear patterns, it may not work, but in linear patterns, it does. It's as useful as possible. So 3n plus 17, I got to test it out just to make sure that I'm correct. So I'm going to test it out. I'm going to take the third number, which is 26. I'm going to write 3 times 3 plus 17, right? It's so important to include your constant in your, should equal 26. 3 times 3 is 9, plus 17 equals 26. 9 plus 17 is 26, which equals 26, which means that I did it correctly. But here's the application piece. I said in the first row there's 20, the second row there's 23, third row is 26. What if I wanted to know how many seats they were in row 12? So what would I do? Well, I'd take the pattern rule, 3n plus 17, and I would, instead of the n, I would replace it with 12, right? So I'd write 3 times 12 plus 17. And then I'm going to put my equal sign on the outside because I'm trying to figure it out. This is an algebraic expression, right? There is no equal sign here, so it's not an equation. 3 times 12 is 36 plus 17. 36 plus 17 is 53. And so I can quite easily say by using this pattern rule that there are going to be 53 seats in the 12th row of this theater. And I could check it if I really wanted to. I could check it by counting up the different rows, or I could add to my term chart if I really wanted to, okay? Let's do another one. A marching band has 3 people in line 1 of the marching band, 5 people in line 2, and 7 in line 3. Let's write a pattern rule for this. So let's create our chart, term number, term value. How many numbers do we have? We've got term 1, which is here, term 2, which is here, and term 3, which is there. So we've got 3 numbers, 1, 2, and 3. And those numbers are equal to 3, 5, and 7. Okay, created my chart. Let's figure out what the next steps are. How am I getting from 3 to 5? Well, I'm increasing by 2. I'm increasing by 2. The 2 then, that's right, becomes my helpful partner in crime. So my new one is 2n. Okay, try it out. 2 times 1, right, should equal 3. Oh, it definitely doesn't though. 2 equals 3. How am I going to get from 2 to 3? I'm going to have to add 1. So I'm going to add 1 to my pattern rule. If I wanted to do term 0, I would subtract 2, and I would get 1. Well, look at that. Same thing, positive 1. Try it out. I know it's pretty much correct, but let's just try it out anyway. 2 times 3 plus 1 should equal 7. 2 times 3 is 6. 6 plus 1 equals 7. I'm so good. I'm amazing. But again, let's add the application piece. What if I wanted to find out how many musicians were in row? Let's go with row 11 this time. What are you doing? You're going to repeat your pattern rule, 2n plus 1. And this time you're going to include 11 as your variable, plus 1. 2 times 11 is 22, plus 1. 23 musicians in row 11. Beautifully done. Okay. Let's try another one, guys. Keep going. I want you to feel comfortable. I know that some of you might already get this pattern, but this is the one where most people struggle. We talked about it, and this is, I think, is a good time to actually bring it into account. What if there is no linear pattern? I'm going to show you one of the quick tips that I would give you going forward if there's no linear pattern, and it's this. So let's say I created my chart already. Term number, term value. Let's say that number, I again was given 3 numbers, and it's, I'm going to put 2, 5, and 10. So I do what I usually do, and I check to see what the pattern growth is or decreases. And this one goes up by 3, but this one goes up by 5. So the issue here is I'm left with a nonlinear equation, a nonlinear pattern. So the best way to check that out, and the best suggestion I would have, is to think of it as squared. What I'm noticing here is 1 squared is 1, and this is 2, so that's 1 more than that. 2 squared is 4, and this is 1 more than that. 3 squared is 9. So what we're going to try to do is we're going to say, instead of using these numbers as my counterpart, I'm actually going to create a pattern rule that says n squared. So n being the term number, squared should give me, so let's try it out. So 1 squared equals 2. 1 times 1 is 1, which equals 2. Again, the same rule applies. How did I get from here to here? Well, I added 1. So I'm going to add that to my term pattern rule. I can test it out, right? Let's use number 3. 3 squared plus 1 should equal 10. 3 times 3 is 9, plus 1 equals 10, and then 10 equals 10. So when you're given a nonlinear pattern, most often it will be the fact that you're going to be squaring the variable. So just something to think about as we go on. That's when you notice that there's no constant pattern upgrade. Okay, we're not going to do many of these, but I did want to just teach you it very quickly. If you looked at going backwards, what do you think the next one would be? It would be probably an increase by 1, right? Because these are growing by 2. But let's go back to something that we are going to talk about. So there was this really, really cool thing called Halley's Comet. And it was seen in the first ever time was in 1758. Okay. And it comes back every 76 years. It's pretty crazy. So if the first thing I would want you to do is I'd want you to create a chart showing all of its appearances. or maybe the first 5. Yeah, let's do that. Showing 5 appearances. Now here's the application piece, why it's important to think about this through. Your first, so you're gonna have 5, you're gonna create your term number chart. So we'll have TN and TV. 1, 2, 3, 4, 5. What do you think your first number would be? What do you think your first number would be? This is the challenging part, because your first number is actually going to be not 1758, because 1758 is your 0 term, right? That's the birth of it kind of thing. So your first actual one would be 76 years later, right? So this would be 1834. We keep going down, 1910. Next one is 1986, and then 2060. We'll leave it out there. You know, we'll do the first 4, okay? So the reason I showed you this is because you're given a little bit of your constant here, because you know that that 1758 is never gonna change. It's always gonna be the birth of this thing when it was first seen. So what do? Well, you look and you see, okay, how is this increasing? It's increasing by 76 years. So because it's increasing by 76 years, you can easily say that 76 is going to be your variable. And you've already got your constant, right? It's 1758. Because that's the number that is your term 0. So whatever appearance you're looking for, you multiply it by 76 and add 1758. So if I wanted to ask you when the 10th sighting was, when is the 10th sighting going to be? So what you're going to do is you're going to take your variable, okay, 76 times 10 is 760. Plus 1758. Mr. Berger didn't do this math earlier. Sorry, guys. I'm just realizing it in my notes. It is 15. Oh, guys, I hope to see you there at the 10th one, which is going to happen in 2518. Okay? So again, this one is a little bit trickier because you most likely would have put 1758 here, but you have to understand that it's been given you as the original occurrence, so it's got to be term 0. This is from the grade 9 textbook, so that's why I wanted to take you through it really quickly. Let's do another grade. Oh my goodness, sorry guys. That's the first time that's happened. Let's do another grade 8 one, and this one I'm going to get you guys to try on your own. Here's the pattern I'd like you to attempt: 101, 201, 301. 401, and I want you to tell me the following things. I want you to tell me what the pattern rule is, so the nth term, and I want you to tell me what the 50th term would be in this pattern. Okay, so pause and go try to figure it out. Okay, so you're back. So we should have gone through all the steps. Let's create our chart. Term number, term value. We've got 4 numbers here. The first one's 101, 201, 301, 401. You were to identify how much it was growing by. So from 101 to 201, it's increasing by 100. And all of them look like they're increasing by 100. So at that point, you should have had 100n down. Now, what you did at this point could have been the following. You could have done this step, which is to test it out. 100n equals the term value, which in this case, 100 times 1 should equal 101. Well, we know that this is not going to equal out, so you have to add, 101. You have to add 1 here. So then I would add 1 here. So you could have done it that way, or if you were a little bit more comfortable with it, you could have said, okay, what's term 0? So if I'm going adding 100, I'm going to subtract 100, and I'll get 1. And that would have given you. And then obviously that would have been your part 1. You would have got your pattern rule, which is 100n plus 1. But then part 2, you had to figure out the 50th term. So you would have said 100 times 50, right? The n gets represented by the new term, plus 1. 100 times 50 is 5,000, plus 1. So the 50th term would have been 5,001. Okay, hopefully you got that. If you didn't, take a look at the steps that we did here to see if you can get that. Okay, let's do another one. Let's do another one together. This one a little bit different than what we've done before. So let's do this number pattern: 29, 27, 25, 23, 21. Okay. So again, creating our table. I told you I'm gonna bang this until we can't take it anymore. We got 5, so let's do 5, 29, 27, 25, 23, 21. At this point, your brains said, okay, whoa, we're actually shrinking by 2. We're -2, -2, -2. All this is -2. So here's what you could do here. You could say to yourself, I'm going to put this -2n, right? Because it's a -2, I'm still going to use that -2 at the beginning of my variable. So I'm going to try this out now. This would have been an amazing spot to use term 0, because I know that there's going to be a difference between 1 and 29. So I could test it out. -2 times 1 equals 29. So -2 equals 29. How do I get from -2 to 29? Some people don't love working with integers, right? To get from -2 to 29, I actually have to add 31, right? If I had done the term 0, I could have said, okay, if I'm going -2, then I'm going to go +2, and I'll get 31. So I could write my term out as -2 plus 31, -2n plus 31, or I could write 31 minus 2n. Okay, I'm just going to erase this right here so you can just kind of see it clearly. It's whichever you're more comfortable with. This way, it might be a little bit of a struggle, whereas this way, it might be a little bit easier. Now, if I asked you to find the 50th term, I'm going to show you how it can look both ways, right? In this way, 31 minus 2 times 50, you're going to get 31 minus 100, and you're working backwards, right? So you know that it's going to be a negative because this number is bigger and it has the negative sign. So it's -69, ha 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 ha. But if I had done it this way, -2n plus 31, it would have been -100 plus 31. It's whichever way you feel comfortable writing it, both ways written is correct, right? Because 31 minus 2n, this 31 is a positive, right? So you're still getting that positive. So whichever way you choose to write it is up to you. Let's do one more of you guys trying on your own before we head to the thinking section. So I want to know in this pattern of, in this pattern of 5, 7, 9, 11, I want to know the pattern rule. And I want to know the 50th term. You know what? 150th term. Let's do that. I like it. Okay, go. Take a pause and figure it out. Okay, you're back. Excellent. I'm hoping that it was a very easy one for you. Mr. Berger's term value chart. 1, 2, 3, 4, 5, 7, 9, 11. I know that I'm just repeating the similar ones that are going, so we're going to go up by 2 here, which means it's 2n. At this point, I'm going to use for this one, I'm going to use the term 0. So I went up by 2, so I'm going to go back by 2. So my constant is going to be plus 3. Let's test it out really quickly just to verify. 2 times 3 plus 3 should equal 9. 2 times 3 is 6 plus 3 equals 9. 9 equals 9. Okay, good. Amazing. My pattern rule works. What's the 150th term? So let's take it and let's go with it. So 2 times 150 plus 3. So the 150th term is 300 plus 3. It's 303. Well done. Hopefully you got that. If you didn't, take a look at the steps that we did to get here. Okay, that's it for the application section. I will see you in the thinking section where we will do some more challenging ones. See you in a bit.